the next joint workshop between Philipp Yuan's team and our team in Stuttgart. And this time we take the international approach very seriously by the team of the workshop being spread out all over the globe. So I think that's fantastic. And I'm very much looking forward to this week of intense workshop with you. I think it will be super exciting. And I think we have the great opportunity to turn this difficult moment into an opportunity by looking at how far digital technologies allow us to still operate and do this great experiment of having a workshop team offsite and then having an execution team on site. So I think this will be a great experiment. I also would like to take the opportunity before I hand over to Philipp to thank Philipp and his team, who, as always, have prepared everything in the most meticulous manner and have now, for more than a decade, run these absolutely fantastic workshops that we have been participating over the last few years. So thanks a lot. I think it's a fantastic initiative. And I think this year, especially, you have really raised the bar and sort of upped the game by turning it into a truly international I think event that has also received attention globally. So fantastic.
Great. Thanks to Achim and also Hans Wagner, Caihua, and also we have Mohammed Moisen here. So it's a great honor to teach with you guys. And also here is Alisa, right? How to pronounce? Yeah. So welcome to join the team. It's a great opportunity this year. I think this is the 10th Digital Futures, but it's really special for the coronavirus post-pandemic era. Achim and me, we still great support this event, and we try to set up a very interesting international global platform right now. We have 80 workshops, so this workshop is one of them, and we make different selection through a very big applicants, very high quality applicants. So all the participants very lucky. We prepare for this workshop for almost 5-6 months, including set up a robotic institute platform, which is special focus on the timber structure manufacture. So it's like a testing or experimental platform. And we try to design and construct a very special pavilion in a very short time. So here is a space. From next month, we want to set up a new robotic factory here nearby Tongji University. So it's like 20 minutes away from the campus, around 8,000 square meters. So right now it's empty warehouse. The robotics just moving here this morning. So they spend like 4 or 5 hours set up everything. And we are try to design the pavilion. And this pavilion, looking forward to be a permanent bicycle parking pavilion in the entrance. So it's not a big budget, but we hope we are looking forward. All the small object on the site in this space is experimental. We want to test different kind of technology, different kind of material, performance material technology here in the renovation process. So next year, if it's possible, Achim, you are welcome to visit Shanghai and to working with us on this special platform. So, and also I want to introduce 3 team members here. Ms. Guo, and she is very helpful, help working on this platform. And she just graduated from University of Darmstadt, right? Last year, and right now she is a researcher in my team, focused on the platform engineer and some R&D work. And the others are my graduate students. So they have a very intense connection with Chaihua in the past 2 months. I think they're preparing for this workshop for a long time. So generally speaking, it's a great honor to working with ICD, with Achim. I think it's a long-term friendship sponsored by Sino uh, DFG program. Actually, Achim and me, we published a Chinese edition robotic technology book last month, which is a very high-end book series in building construction technology, which is the largest construction press in China, and it's national funding sponsored. The book is published, and also we introduce ICD's work and um, um, uh, our team's work in the book. I think there are a lot of productions. Workshop is another thing. This is actually, I think, Achim is the fifth or the sixth one we collaborate together. So in the past 5 years, Achim sent his team from ICD. We're working together in Shenzhen for a pavilion, and also in Shanghai there is a permanent pavilion located at the corner of the Shanghai Westbound, and also in Digital Future, Ahim already, your ICD team already participate 5 times, I think. So Ahim play a very important leading roles globally, not only in Europe but also in China. So in Shanghai, and all the students know your name, and ICD is very famous here in China. So I think it's a platform to introduce all the high-end technology and the best research team to the world. I think also the young generation, they're looking forward to follow the. I think we want to open a lot of technology. Actually, last year we released FU Robot to GitHub, and for some of the very early version, EDA version, how to make use of the robotics. We already released some of the things open source. I think that is try to encourage more young generations to join us to the robotic fabrication in the future. I think right now, in the past year, there is more than 10 universities by new robotics in China, which is especially promoted by Digital Future platform. So I'm looking forward to the industry revolution, the update of the architecture industry should be promoted by the team and by some leading figures like Ahim. I think we should collaborate together to do some more experimental and more meaningful work together. And thanks to Ahim and to the teams. I'm looking forward to have a very good pavilion coming out 8 days later. So it's a very intense workshop. Thank you. So yeah, Chaihua, would you like to say something or Hans? Chaihua,你没有开话筒。
Oh, can you hear me now?
Yes.
Yes.
Oh, sorry. Hello, everyone. It's very glad to meet you all, and it's also a great honor to set up this workshop together with Professor Mangus, Professor Yuan, and also great honor to work with Jakob here in ICD. And maybe I first apologize for my lousy English, so you have to have to listen to my English in the following few days. So, I'm also very looking forward to work with you guys, and hope we have a very nice workshop. And I hope you can learn what you want here. And also, I'm very looking forward to see the pavilion in Shanghai and
very thanks to my fellows in Shanghai who is working very hard on this project. And yeah, that's it. So we're looking forward to this to work with working with you guys. Thanks.
Yeah, then also hello from my side. There's not so much left to say. I mean, I'm super excited as well to have the opportunity to join here in this workshop. I think it's somewhat of a pity that that we don't do it in Shanghai. I think we have set up, or Professor Huan and the colleagues in China have set up a pretty exciting robotic fabrication platform, which we, I think, would have all liked to get our hands on. But I think also, given the moment that the world is in right now, I think it's the best we can do. And actually, as Achim said, I think it's actually quite exciting to see how a collaboration across the globe on a shared fabrication task can work. And I think Chai-Hu and me also have prepared a couple of exercises and introductions, tutorials, and skill ups that are meant to be taught as a digital workshop. So I think we're excited to get this started, and we hope we can entice you with this workshop.
Okay.
Great.
I think you already set up the schedule. Maybe would you please introduce the schedule? Yeah, and we can start. Right?
Sure.
Maybe here we can introduce the platform right now. Would you like to?你们看了吗？那个
I think Philip may have to turn on his camera on his iPhone. No?
Yeah. Wait a moment. 哎，怎么样能把那个背景去掉？背景怎么去掉？ Okay, so here is the platform. Actually, this is the eighth one, the eighth version we tested in the last 7 years. And this one is more focused on the robotic craftsmanship, timber craftsmanship for some small pieces. And in the future, it also can be transferred to some brick mansion platform and also hot wire mailing platform. Because right now we subdivided the platform into on-site and in-situ, so two kinds of platform. So this one is very intense because we spend a long time to put everything together. totally the weight for it is like 1.8 tons. It's very heavy, but it should be strong enough to overpass all kinds of threshold on the construction site. So normally the construction site is not very flat. It's in different kind of spatial. It's we test it for crossing through different kind of construction sites. So shall we start? The effector here is we integrate two kinds of tools on the two head on the effectors. One is for picking, because we need to picking the pole and to middling them or to widen them on the different construction site. And also another one here is about milling, right? This is milling machine, so it's all integrated. And we have different kind of sensors put on the top. We right now have like three kinds of different sensors and testing the distance and testing the pressure. And in the future, we want to install more sensors for different kind of functions. Yes. And here is a tag, you see, because we need to categorize the construction process and the different kind of components by this kind of tag, right? I think last year, Akim, one of your students making the moving mobile also use this kind of tag technology. So there's different categories. Right now we have two kinds of components. So this could be modified by project. How long for this kind of components? And here you can see the components, something like this, right? So right now it's like 10% speed. It's a little bit slow. Right? This is just for test, right? Just put it here. And on the top of it, in the back of it, we have different kind of effectors for different kind of functions. Here we have a saw, a flat saw here, and for cutting maybe large pieces, could be easily the robotic arm take each small pieces, and the saw can cut it here. And this one is coming. Maybe tomorrow you can see some different effectors put in here. 我们还有哪几个？这个是什么？是不胶的。This one is for the glue, because we need to it's glue and yeah, on top of it. And in the next few days you can see what's happening. Here is also some very easy factors installed on it. So totally how many right now? Have 4? 5. We have 7 effectors put on the back and on top of it. So it's kind of a multi-function robotic timber manufacture platform for some small project, right? Okay, that's a very brief introduction. Maybe the next few days you can introduce precisely in English how to make use different kind of things. And also we have a on-site mapping system. It's kind of we put different place on the space, and for the ultra ray is 红外线吗？还是红外线叫什么 ？Ultra ray. Yeah, so translate English to precisely position the each component on this custom site. So I think Akim, you already have all this kind of technology in ICD, but I think this one is quite integrate for the multifunctional manufacture tools, or intensely put on one platform, and it's super small. Could be moving into the lift, construction lift, and moving to different location on site. And actually, this is the 8th edition. We have the other edition parallel going on, including climbing the wall parallel with the lift, and including 9 meters lift platform. So it's different kind of family of the institute platform. We're making research, and in the near future, we're looking forward to present more scenarios. We already do a lot of real project in China, and the 2 or 3 were coming out this year with this kind of on-site robotics, which is going on. The construction side is going on. I think maybe this year or next year, if after the pandemic era, we want to organize some site visit to this kind of project, how we implement this kind of tools right now and push it very fast to different kind of real construction scenarios. So that's the very brief introduction. Maybe not very precise, but in the next few days, Chaihua and Bo, they can give more interesting teaching progress for it. Okay. Okay. Okay, I'm in.
Okay, thank you. Very exciting to see this last version. Looking forward to seeing it in person one day. But I guess now it's time to leave you guys to the actual workshop. Jakob, are you going to present the agenda and the schedule and all this?
Yeah, so let me share my screen. I hope that works. Can you see my screen?
Yes.
Great. So today we will start off with the workshop introduction kind of presentation that Chaihua and me are gonna run through, and then we'll have a quick session of organizational matters, and we'll give all the participants the chance to get to know each other, and I think we are also very excited to get to know you. And then we have some more in-depth introduction into the context of timber construction and its relevance and its context. And then in the last 2 hours of today's session, we'll have a quick introduction to computational design basics applied to what we are gonna pursue in the workshop this week. But I think at a level that is very much suitable for getting everyone started. And then if you want, you can see the schedule for the next days. We sent it out to all the participants, and you can also see it in each of the videos of the workshop playlist on YouTube. And yeah, I think we'd like to thank Professor Menges and Professor Yuan for taking the time. Both of you are very, very busy these days. So I think thanks very much to joining us in here. And maybe we can have a very quick session of if there is any questions to you guys from the participants before we go on with the workshop introduction. Okay, 10 seconds left to ask.
I may just want to add that I think today we also have our talk at 12 o'clock, or the talk will be streamed actually.
Yeah.
So make sure that you also watch that.
Yeah.
I thought it is a very fascinating conversation.
Yeah. So that's actually very. It fits ideal. So we finish the workshop and then we can all go and listen to the conversation about the post-pandemic future.
Good.
All right.
So have fun. I'm sure it will be a super exciting week.
Yeah.
Bye-bye.
Bye.
Okay. Then let's introduce a bit more the workshop. First, I think Philip Juan already somehow introduced all the team, but here's a quick overview of all the people involved. We have Chai Hua and me teaching the workshop the 7 days. With Professor Menges and Professor Wan doing the supervision. And we have a large team in China, in Shanghai, both from Fab Union and from Tongji University. And we have also some experts involved from ICD, mostly on the computer vision part. With that, we can start with the workshop introduction. And to give you a quick idea of what we're actually going for, I think in general, this is a chance for us to teach some of the tools and the methods that we're using in research. But I think the greater aspiration of the overall workshop is to push together the boundaries of timber construction and to explore what is possible or what might be possible in the near future to both plan and produce. And with that, we'd like to give you a bit of a clearer introduction of what is actually the topic. So we're gonna mostly talk about multi-story timber typologies. And the hypothesis is that we can push these typologies or we can extend the types of buildings that are addressable with timber construction through a platform-based robotic timber construction approach. And if we take a look into the state of the art of timber construction, we can see that there's a a global hype, or there's a trend that really pushes the timber construction forward. I think around the world there is a lot going on, mostly based on the CLT development. But if we see the way these timber buildings are constructed, we can easily conclude that they're quite restricted, and they're applicable to certain typologies, student dorms, hotels, and so forth, but really not yet for everything that we want to do. So we really are interested in developing building system and fabrication technologies that can push those boundaries and can push timber construction beyond the grid. And we hope that in this workshop we can explore new topologies and spatial conditions that might be possible with timber construction in the near future. As timber is a fibrous material, it is anisotropic. And
Hello?
yes?
Yeah, there's a block at the right of your screen.
Oh, wait. Let me remove it. Now better?
Yeah.
Okay, great. So as a unidirectional material, timber construction kind of lends itself to unidirectional spans. But there is possibilities to introduce multidirectional systems in timber construction. And that's exactly what we want to do here. And as an extended thought, we really are interested in pushing from a grid approach to a network approach, where a network is way more flexible to address specific conditions. And at the same time, a network approach might also be helpful to address material efficiency approach to timber construction, as you can, in a network, arrange your material more freely. That means you can also include structural optimization into your computational design approach. And initial studies that were done at ICT showed that with just arranging the material specific to the load conditions, you can achieve 20% of material savings. And so this is kind of what we're trying to do. We're gonna run through together with all of you through the setting of boundary conditions. I think we're really interested in pushing the boundaries further. We're gonna run through, let's say, computational analysis. We're not gonna really focus on the structural analysis and the simulation, because simply it's not our expertise, but rather we are interested in how this could conceptually involve or conceptually inform the tectonic layer of the slab. Then we're going to talk about how to actually plan a beam arrangement in such a slab. And we have both the aspiration of running through the progress of individual projects with all of you guys. So you're going to have the opportunity to design your own structure that showcases a certain spatial quality. And at the same time, as you might have understood from Philip Huan's introduction, the guys in Shanghai are, while we are teaching this workshop, they will start to produce a demonstrator structure directly next to the Union building in Shanghai. The tectonics of these support beam structures are obviously very intricate. We're currently proposing that they're made out of timber laths that are glued together automatically with the robot. That gives us the opportunity to really design each of those timber pieces. But at the same time, obviously, it comes with computational challenges to handle the complexity of these beams, which we're going to run through in the workshop. And I think this could be a very interesting building system of how to address this kind of multi-directional freedom in. We already saw the real mobile timber fabrication platform as it is sitting in in the factory. Just a quick overview here again. So you have the track platform that allows the robot to move freely. It also has supports so that it can have a very stable position during the operation. The robot controller is directly on the platform. We have a glue application head where the robot can pass through the sticks to apply the glue on the sticks. We have a timber stack input of the elements. We're working with an ABB IRB 4600 robot. You can see the reach of the robot on the right side. So it's ideally suited to both work on the ceiling area as well as on the floor area. Right? And we're going to see why this is very important soon. So in general, the fabrication process involves 5 steps, where the first step is a calibration of the robot in the space. We assume that the fabrication tolerances are somewhat between 5 and 10 millimeters, which means that to achieve a high accuracy, we might want to scan the actually built structure before placing the next stick. So then the second step is to grip the beam from the stack. We apply the glue. We position the beam and we fix it with the nails. And the nails really are only for holding the pieces in place until the glue hardens. Now with this kind of building system, there is 2 construction assembly approaches. There's one scenario where we say we have a base plate that is already erected on site, and the robot runs below the ceiling and reinforces the structure from below. We have also a second scenario where you can say, actually, it might be better if all the panels are laid out flat on the floor, and the robot is actually able to both walk on top of those plates while reinforcing them with the beams. This would obviously entail that you later need to raise the whole ceiling. But still, this might be quite interesting because it enables really a very easy and flexible production method on site. So this is a quick video showing the procedure. And here you can see the sequential reinforcement of the slab. Okay, so as I mentioned, the goal of the workshop is to collectively explore the spatial, structural, and topological potentials of such an on-site fabricated multi-directional timber slab. And we really are excited to see how this could push forward wooden architecture. The way that we will run through with you is that we have kind of 5 research areas that we are focusing on. And the first one is the definition of the boundary situations. So here, each of you, or in groups, you will design your own condition that you want to explore. And what we want to stress is that really we are interested in systems that involve a set of columns, a slab that shows new ways of new spatial and geometric situations in timber construction, and really a slab that has multi-directional spans, right? So a boundary condition that is really hard to address with strict grids and unidirectional building systems. Then in the second step, we have a computational analysis area where we will introduce ways of how you can generate networks that are informed by structural simulation. The most accessible tool that we found is Topos. It's a topology optimization tool. There's a lot of assumptions that we do in terms of the structural validity of these tools, which maybe are not the core focus areas of this workshop, but rather the idea is that if we have a way to inform our slab with complex networks, right? How could they look like, and what would be the topology of such networks, and what are the possibilities that arise with that? After we generate those networks, the real question is how they materialize, right? And how we can make the step from a pure computational topology map to really articulated tectonic expression of the material system. This is a very challenging step, and we developed some tools that achieve that. But here, really, you as the workshop participants are also invited to push the boundaries together with us and figure out maybe new ways of how this could be achieved. Then we have the fabrication sequence. Here we will introduce you to the robotic simulation platform that was developed at Fab Union and Tonji by the colleagues. And this will enable you to really simulate the whole fabrication sequence. And this is important because we really want to integrate the fabrication with the design, right? So you might realize that a certain spatial condition might not be possible to fabricate with the setup as we have it, right? And then the idea is that through the direct and accessible fabrication simulation, you'll be able to adapt your design accordingly. There's a couple of different approaches of how you can sequence the fabrication. You can build the beams layer by layer. or you can kind of optimize the fabrication sequence so that the fabricator has a minimum of repositioning movements to do. And at the end of the workshop, we're really looking at your demonstrative outcome. So here you're going to work in groups of, I think, 2 people. We'll also maybe discuss that a bit later. And all of you guys are going to have the chance to first develop your own structure, and at the same time present it also later. This is the pavilion structure, or the slab structure that we're currently planning to produce in Shanghai. So while we're running this workshop, the colleagues in China are going to work on the structure that you can see here. And maybe we'll have the chance to stay in contact with them, maybe have some live streams or video chats with them while they are producing it. But really what we're looking for in the digital workshop, or in this kind of seven-day workshop, is your own individual demonstrator structure that is obviously shown digitally. Okay, with that we come to a bit of a organizational matter. I see there is a question from Ali Reza. Are we defining the boundary conditions ourselves, or we have limitations by the site or other conditions? Okay, so that's a really good question. And really, let me just find the red slide. Can you see the slide now?
Yes.
So really the idea is that you, as the participants, define your own boundary conditions, right? So I think as you come from partly from practice, you come from design schools, and you might have all experienced already the wish to express more freely a spatial condition in timber construction. And really we are interested in what you would think might be interesting to explore with such a building system. I think I need to quickly check the stream to the live stream. I lost the presentation.
Can you, yeah, there's a question from Snow. Can you explain more about the logic of the big layout from the structure analysis? Jakob?
Yeah.
Jakob?
Yes.
Can you move the slide to the design process?
Yes.
Yeah, we have more questions.
Which slide?
And maybe the
This one?
21st. Yeah. And about the logic of the beam layout, we are using the typological optimization method to get the patterns, and we developed some tools that could be used as a demonstrator for you guys, so you can understand how the process works. And also we developed some tools to generate the tectonic articulation from the network. And you can we can also share that in the next few days. And but I think as we encourage you guys to define your own boundary conditions. And I think it's also free to develop your own tools to generate the network and the tectonic system. But if you are not that good at computational designs, you can also use the tools we provide.
Okay, I'll quickly need to restart PowerPoint because somehow the capture for the live stream did not work.
So maybe I will keep answering the questions while you are solving the question, solving the problem of the online streaming.
Okay, I think the slides are good now. Okay, we're good to go. What was the next question?
I think is there any constraint about this boundary condition, like can't be too complicated? I think the boundary condition is more free if you just take the structure aspect into consideration. And I think the tools we provided may works on very complicated 2D slab system. But if you want to develop your own tools, I think that would be your question, whether to have the system to have a complicated system or not. I answered the question clearly.
Yeah, so I think the question is not to make the boundary conditions as complex as possible, right? But definitely, I agree with Ben that with the robotic setup, with this kind of building system, we're put in a position where we can actually explore more complex boundary conditions, right? And really, I think the question is not how complex can we make it, right? but the question is like, what are the spatial conditions that that would improve the architectural quality of multi-story timber architecture with such a building system, right? And I think the real complexity will kind of naturally come with that, as you might want to explore maybe undulating slabs or kind of auditorium-like conditions like here, and then I think in the workshop we're well equipped to address all these questions. Okay, are there more questions? Yes. Can you share something from this? Can you share something about the structural behavior of the strengthening tectonic pattern during this week? As in, how does the slat pattern work, behave compared to, for example, a normal beam? Any thoughts on or research done on this to share? So we'll have Simon Bechert from ITKE, who is the Structural Engineering Institute that we at ICD are collaborating a lot. He's gonna come in on Thursday. He's gonna present a couple of projects, couple of experiences as a structural engineer on these kind of systems, and maybe he can also answer some questions about the structural behavior of these beams. At the current moment, this is all a conceptual system that didn't really receive in-depth structural research. At the same time, as the beams are glued together, we assume that it might be structurally quite performant. But it will also very much depend on the way that the beams are arranged, right, and how much they overlap and how much they're segmented and so forth. Okay, next question. The parameters we define are just the boundary conditions, and the positions of the column, and the span is the answer of the analysis and the optimization. Yes, so I think a lot of the parameters are gonna be kind of dependent on the boundary condition, but there is a lot of design decisions that still need to be done, need to be made after the setting of the boundary condition. So I think the boundary conditions are only the onset, right? I think here we really are excited to see your, let's say, creative ideas. But then I think the real work will start after you defined your boundary conditions, and then you really want to work out the details of this. Are we going to dive? Dive deep into the details of the optimization algorithm, Jahul?
Yeah, in this workshop, we will teach you how to use a structure optimization plugin called Topaz. I think for us, it's just a tool to generate our beam networks. But if you means deep into the detail of the algorithm, we are not going to like very deep to maybe the source code of the optimization algorithm, but you will have the program useful for this project that could you take your take your boundary condition at input and output what we want for our structure definition, and we also will explain how it works from the input to the output. Yeah.
Are we restricted by the number and the size of the timber? So yes and no. I think the whole idea of having the on-site fabrication platform is that the slab can literally be unlimited in size, because the robot, let's say, has no spatial restrictions of where to walk to. Right? At the same time, for the robot to handle the timber laths, right, the laths need to be a certain dimension. Right? So I think the slab itself won't be limited in size. Obviously, it's going to get more and more computational heavy the bigger the structure gets. But the tectonic elements will need to be very much integrated in their dimension with the robotic fabricator. Okay. From Jennifer, how did you fix the column position during the boundary definition step? What are the parameters to consider while doing this? So here we typically, I think this is mostly up to you, right? So I think this is really the question of what we can do with columns in an architectural space if we have the freedom to position them almost wherever we want, right? But at the same time, of course, there is, let's say, a certain span that we think is addressable with such a system. And I would say for the structure that we build in Tongji, I think the maximum span is like 5 meters or 6 meters. Obviously, this could be improved with further research. But I think for the demonstrator projects, I think if you have a span of 7 meters, conceptually, I think that would be kind of okay. But 7 meters might be like very, very challenging to actually achieve. But well, it depends on what kind of timber you're going to use and how the quality of the production. So
the large spans will also increase the beam height, or maybe also the thickness of the plates. But to define the parameters, or to define how large the spans, maybe we need more expert on the structure aspect. But in our case, we just maybe just keep it in a reasonable span of a reasonable cantilever. Do not challenge too much about
okay, question from Ben is about the gluing process. So this is that depends also. Maybe I'll read the question. My understanding is that glued timber products, example given LVL and glulam, must be cured in a pressure chamber to develop a strong joint. Do your built-up glued beams act as a monolithic member, or are the glued interfaces significantly weaker than the timber? So this is a question of material science, right? Which we won't be able to address in the workshop. I think from my side, I can only say that that the development of different glues for timber construction is very much advancing every year, and there already exist gluing systems that are able to that can be used on site, right, without pressure chambers. A lot of them still need to have a certain amount of pressure between the two components, but even there is glues that can bridge the gap between, let's say loosely attached pieces. With the main advantage that then you just also need a lot more glue. So in the fabrication system in Tonchi, we're going to use PUR glue, which is a one component glue and hardens with humidity, and that means you don't need special temperature, you don't need a special environment. You just need to ensure that your wood has a proper moisture and that you're not working in like low humidity environments. But we're not gonna. So this is like a very important question in terms of application of such systems in the industry. I might be able to also go a bit into detail of what all the steps were to ensure the proper bond in the glued cassettes of the Buga wood pavilion that we built last year, which was also robotically glued with PUR, but involved like a lot of special reports from experts in the industry to get that actually approved.
I think we missed one question.
Okay. You want to read it?
How to make sure the flatness of the ceiling while assembling the beams. In my mind, I think we don't have to make sure the ceiling is totally flat. Actually, is as you know, when we're proposing the slab, it's should be a slab that composed a lot of smaller slabs that could be transported on site and then assembled to a large slab just on site. So the on-site assembly, I think, would not ensure the slab to be totally flat, but for the fabrication process, if you notice it, when Professor Yuan introduced the platform, there's a camera mounted on the robot. So the camera will is used to collaborate with the robot and also try to see the elements and see the plates. So that's what we do to avoid the errors that caused by the unflatness of the plates or other environment parameters. And yeah, I think the robotic fabrication process itself will just take the errors in, so we don't need to make sure the total flatness.
Okay, Alireza had another question about the calibration of the robot while it's moving around. So this is a very up and coming topic in robotic fabrication, where where obviously the challenge is to achieve high accuracy. And in our system, we currently have even 3 different approaches. So first, we work with a lighthouse tracking system that you might know from the Vive gaming console, from the virtual reality glasses, which is actually highly accurate, but it needs external sensors, right? So you have these lighthouse boxes that also Philip Juan showed during the tour. Then we have a camera system on the robot based on a depth camera, RGB depth camera, which can localize tags that are positioned in the environment of the fabrication. And a third approach, which is the most ambitious, but also maybe the most applicable in the industry, is actually to, with these depth cameras, scan the beam structure and understand the local condition of the already fabricated structure and adapt your fabrication to the structure that is already built. We'll maybe have the chance to show you how this works on site, but yeah, we would need to organize that. Okay, last question before we go on. Okay, it's not a question, but thanks, Ben.
It's the one from Jennifer.
Oh, yeah, there is another one. I noticed that the number of timber members overlapping in different parts of the structure is not the same. Can you explain a little more why that difference is? So, Rahul, you want to answer, or should I?
You mean the thickness of the beams at different parts of the beams, right?
So,
yeah, when we make this system, there is also maybe tools that we developed to optimize the height of the beams. So you all know when we talk about the beam, the height of the beam is very important to its structural performance. So after we make the simulation, we use we just put more beams on at where the maybe the stress or the density of the element is higher, and put less beams where the structure performance it don't need that much beams. So that's also our way to make the structure more efficient, I think, and just more beams on higher stress and less beams where the stress is lower. Yeah.
Okay, question from Mahmoud. Are columns connected to the slab directly or to the beams? In the structure that we are building in Shanghai, we chose the columns basically connect to the main plate on top, which is a steel detail that is quite common in timber construction. And then the beams are reinforcing the slab. I think structurally, that's for sure a point that can be improved, but might need a very in-depth look at how this connection detail could be. Okay, I think now we have all the questions, right? Yes, we use image processing to calibrate the robot. Okay, now let's go on. I think we're a bit behind time. We just wanted to give you a quick overview of the workshop organization and then run through the participant introductions. First we'll talk a bit about the weekly schedule, then the daily schedule, and give you a quick intro to the guest expert lectures. So the daily workshop routine, which maybe already today we're gonna not achieve, is because we're over time, but in general we aim at 90 minutes of a kind of daily intro with reflections on your projects, and on some days also lectures. Then we'll have a 30-minute break, and then the last 3 hours will be mostly filled with tutorials and interactive skill-up sessions. The daily tutorial focus will be changing from day to day. So if we start today with, as I said, the computational design basics, we'll start off with something quite easy, so that everyone can warm up their grasshopper skills. Then tomorrow there is going to be a big focus on the robotic fabrication. Then on day 3 we'll dive into the computational analysis tools. Then day 4 will focus on the tectonic articulation. Day 5 on the detailed robotic simulation. And on day 6 we'll have more flexible schedule that is less tutorials but more individual tutoring. Then the lectures will be organized in a way that today we're going to present the research relevance and the context for the break. And tomorrow we'll have another lecture about the robotic fabrication state of the art in the research. And then we have quite a few invited guest expert lectures, both from Tonji, ICD, and ITKE. Tomorrow, Lu Ming will introduce the Cool Robot plugin for robotic simulation. Then on Monday, Louis Orozco will give you an overview about the global players in wooden architecture. Anna, also from ICD, will then will talk about the emerging trends and also detailed studies about the typological limitations of wooden architecture. Then on day 5, Felix Amtsberg from ICD is going to talk about the state-of-the-art automation technology in the industry, right? So that's going to be a bit different from all the robots that you're seeing in the research context. But it's also going to be very interesting to understand what are actually the current opportunities in automation in timber construction. And then, as I mentioned already, on Thursday, Simon Bechert, a colleague from ITKE, that's the Structural Engineering Institute at the University of Stuttgart, is gonna give a quick overview of structural engineering in advanced timber work of the last years. So if we kind of map that out in these 5 research core areas, then this is what we kind of envision the project to go forward. I think we'll be also a bit flexible about this. So if you have any questions about something specific that we should touch upon, then just get in contact with us. And then last but not least, on Friday we scheduled the the full day basically to give all of you the chance to present your workshop projects publicly. We'll have about 5 minutes per group for presentation, and we'll have a quite impressive set of international guests from academia and practice. Then hopefully we will have a very interesting conversation with, and this gives you the chance to not only get in contact with us and get free feedback from us, but also will extend the conversation of this topic beyond the academia and beyond our group. Okay. Then on the last 3 hours of Friday, we're planning actually to have a Q&A where all the auditing students are going to have also the chance to connect with us, and maybe we can also have virtual drinks, but that's probably up to each of you and which time zone you're in. But I think that would be great to have a bit of a socializing situation also in this virtual video conferencing situation. Okay, with that, I think we can go to the participant intro and the workshop hours. So what we need to stress is that that we have participants from very different time zones in the workshop. As you might have seen, we are around 30 participants in the Zoom meeting, and that's composed out of basically 2 sets of applicants. There is the Europe time zone applicants, and there is the Asia Pacific workshop applicants. And going through your applications, we saw that probably the mix of different time zones is quite extensive, right? So I think we are kind of comfortably working in time zones from London, Berlin, Moscow, Mumbai, Shanghai to Sydney, right? Which the main daily tutoring and lectures are going to be during the day, right? North America is sadly, or South and North America is sadly very much during the night while we're running the workshop. We ask you all to check these time zones before you apply. But in terms of working together as in groups, it would be super beneficial to understand a bit more which time zone you're actually in. And for that, maybe we can collect from each of you kind of the time zone in, let's say, GMT plus 1 to plus 10, I guess. And with that, we could also just run through each of you guys quickly introducing yourself, and we'll ask you about the time zone that you're currently located at.
Maybe you can all turn your camera on, and we can get to know you.
So many people. Okay, it's actually two pages in the gallery view of Zoom. So maybe I'll turn on the speaker view and we just run through the list. I'll also just post it in the chat so we can do it in coordinated fashion. If you're not in the list, please just let us know, right? Or if we misspell the name or something, I think we just copy it from the applications, but just get in contact with us. Okay, let's start with Vicky.
Hey. Hi, can you hear me?
Yes. Hi.
And this is Vicky. Hi, I'm from MIT University, but then now I'm back in China. So I guess my time zone is past 8. And yeah, so what do I need to talk about? I'm very interested in computational design and digital fabrication, and I have some experience with robotics and done some research projects. So I think this workshop will be a good opportunity to get to know more about timber constructions with platform robotics.
Great. Should we continue with Mahmoud?
Yeah, hello. Hello, everyone. Can you hear me?
Yeah.
Yes.
Yeah, okay. Yeah, my name is Mahmoud. I'm currently in Berlin, GMT +2, I think. I would like first to thank you all for giving me the opportunity to take part in this interesting workshop. I'm actually a licensed architect from Egypt. I have my bachelor degree from Alexandria University. But recently I have a big interest in computational design, and I'm almost finishing my master degree in computational design here from Nordrhein-Westfalen. And I'm particularly interested in elastic plastic material, wood and metal, and I'm working currently on wire bending research for my thesis, and I'm using also computer vision to do the calibration process. Looking forward to see how you do how you use computer vision in calibration with your robots. Yeah. Thanks.
Great. Misbah?
Hi, I'm Misbah, and I'm currently based in London. I've just finished my master's in architecture and urbanism, my design research laboratory at the AA School of Architecture. And like my interest is also in computation, and I thought this would be a great opportunity for me to learn about this timber-based robotics. And I have some experience working with KUKA robots as well. I've done some light drawings, but like it's very primary experience. So I thought this would be a great chance for me to learn more. That's it about me.
Great, thanks. Then Franz.
My name is Franz. I currently live in Norway, in Oslo, where I work at a large Scandinavian firm, and I'm head of the computational design. And we have strong interest in wood, in timber structure, and also member of others innovative organization. And I really look forward to get the maximum knowledge out of your work and eventually make some collaboration in the future to maybe test this technology on real projects in Scandinavia.
Cool. Then Echin?
Hey, hi, this is Christine.
Hi.
Actually, originally from Beijing, and can you hear me?
Yes.
And now, oh, sorry, in Pittsburgh, so the time zone would be like -4, and I have an undergraduate background in architecture and am now a master's student majoring in computational design at Carnegie Mellon. So part of my design and research interest lies in like bio-inspired design and the materialization of digital fabrication. So I'm super excited to be here. Okay, thank you.
Okay, great to have you. Even though it's night time, I guess in your time zone. How to go forward? Ali Reza.
Hello to everyone. Do you have my sound?
Yeah. We see you.
Can you hear me?
Yes.
Yes.
I am Ali Reza Mohammadi, and I am very delightful joining this workshop with all my friends around the world. And I am from Iran. I am finishing my master in Tehran University, and I'm working on my thesis about topology optimization on tall buildings, and I'm working with Karamba, and I have worked in a fab lab with just some robotic fabrications, and we have just built some robots with just kinetic tools and just like Arduino and some like others. And I am very delightful joining and being in this workshop.
Okay.
Thank you.
Your time zone is then +3.
I am just 3 hours and 30 minutes after the Greenwich and GMT hour.
Okay. Great. Raj?
Hello, can you hear me?
Yeah.
Hi everyone, it's a pleasure to be here. I'm calling you guys from London. I'm an ex-grad from a few years back from the Architecture Association, and I've been practicing as an architect at Foster and Partners for a few years now. And I don't have much experience in robotics. I want to take advantage of the workshop to apply computational design to that, and look forward to sharing this interest with you guys.
Great.
Excellent. So you can hear me?
Yeah.
Yes.
Okay. My name's Ben Sittler. I'm doing my PhD, or finishing up this year, in earthquake engineering in Tokyo. So I'm at like GMT +9. But my background's in structural engineering, and it might have frozen.
Yeah.
Okay. It might have frozen there, but you can hear me?
Yeah, you're back now.
Yes.
Okay. Okay. But so I did my undergrad at Princeton in the form finding lab, and then worked for Arup for a number of years. So I had a few projects with timber, so I'm pretty keen to look at that further in this workshop. Yeah.
Great, thank you.
So, hello everybody. This is Chris van der Ploeg from Delft in the Netherlands. And I'm very pleasure to be in this workshop. I think it's a great opportunity to get to know more about, for example, robotic engineering. I work at ABT Consulting Engineers in the Netherlands already for 6 years. Worked there, started as a structural engineer, now leading our digital innovation group. And really, I'm looking for the area where we can apply more computational methods in our structural engineering business. And I think this is a really great example for the future where things will go to. So I'm really looking forward to a really exciting week. Thank you. And GMT +2.
Am I audible? Hi, this is Jennifer Rose from Chennai, which is located in India. I did my undergraduate from IASI and passed out last year. So I'm very much interested in computational design, and I have some work experience during my internship and my studio that I'm working right now. But robotics, I think this would be my first time, and I'm really looking forward for the upcoming 7 days of the workshop. And my time zone is GMT +5.
Great.
Hello, can you hear me?
Yes.
Yes.
Hi, this is Jia, and I'm studying landscape architecture in GSC. But right now I'm on leave, so I guess I'm GMT +8, and I have quite primary experience in computational design, and looking forward to learn more through this workshop. Thank you.
Great. Thanks to have you. Next.
Hi, Snow, we can't hear you.
Hi. Hi, I'm Xuexin Duan. Can call me Snow. I'm a PhD candidate now from Tongji University. I'm very glad to meet everyone here. So I'm at GMT +8. The reason why I'm here, of course, I like Professor Akim's and Philip's work a lot, not only the hyper objects they built, but more about the way they're rethinking the digital design, like the synthesis of machine and the material computation. So looking forward to augment our extended mind with everyone together. Thank you.
Thank you.
Can you hear me?
Yep.
Hey, okay. Hello, everyone. My name is Yicheng Zhang. I come from Beijing, GMT +8. I'm a graduate student in architecture. It's really my honor to have this opportunity to join our workshop. I came across robotic fabrication last year, and I became fascinated with it. Since then, I've been looking forward to join digital future one day. Thank you.
Thank you.
Maybe we stick to the list. Zhang Lang.
Well, can everyone hear me?
Yeah.
This is Zheng Lang, and I'm from University College London, and it's nice to meet you all. I have done some research about digital fabrication before, but this is also my first experience with robotic. Although it's the first time, but I think this must be a really interesting research for all of us. Thank you.
Thank you. So, you're in London or in China right now?
I'm in China now.
Okay. So +8 also.
Hello everyone, my name is Zhou Jing. I'm from China and I'm a student of Tongji University. I don't have much robotic fabrication before, but I hope I can learn more about it in this workshop. Thank you.
Is Ting here?
Yes, here. Can you hear me?
Yes.
I'm Bu Ting, and I'm also a student from Tongji University. And actually, I didn't have any experience in computational design. So it's a great opportunity for me to work with you in this workshop, and looking forward to learning with you in these days. And also, so that is GMT +8. And thank you. That's all.
Thank you.
Zhang Ti, right? Is Zhang Ti here?
Hi, sorry.
Hi.
Hi. Hello, everyone. I'm from Tongji University, Doctor of Engineering. In my English is not very good. I'm glad to compare with the others. I'm I sorry. I did my English is poor. Sorry.
Yeah, welcome. And the next, Yan.
In CAUP. My research direction is rural heritage and heritage conservation. I come here because um, mm, very early I knew Professor Yuan's projection in Zhuli, a multi-functional rural community culture center in Sichuan. So for me, it is an unforgettable project in the countryside. So I want to know about a little about the process and the method of the timber architecture, robotic timber architecture. So that's why I'm here. Thank you.
Thank you. Chen Wan.
Yes, I'm here. Hello, everyone. I'm Chen Wan. I'm now in Guangxi, China, and I'm also the student of Tongji University, and I'm very interested in the wooden architecture and computer computer design, and so I just choose this course, and then I'm very looking forward about sorry I'm looking forward to learn more knowledge from this workshop, and I'm also very happy to spend a good time with all of you. Thank you.
Hi. Hello, guys. I'm Wang Yuxuan. Can you hear me?
Yeah.
Yes.
Yeah. Okay. Thank you. I'm Wang Yuxuan. I'm a new student of the UPenn in the project in the program of the Master of Science in Design, the Robotic and the Autonomous Systems. But now I'm not enrolled in the university, and I graduated from the Southeast University 2 years ago, and during these 2 years, I'm an architect and also the project manager of the project of the kind of transformable mobile house. Nice to meet you, and I wish to learn a lot with you. And I'm in China right now, the GMT +8.
Okay.
Hello everyone, I'm Wu Zhiying. I'm at the Shenzhen now. I'm the student from Tongji University and the GMT +8. I'm honored to attend this work camp because I have known that this camp would actually build some structures with the structure athletics, and it will display the campus results every year and will be used with the real person. And I like to learn more about the digital construction in the action and understand the actual workflow of with the building with the robot. I hope we can study together and cooperate happily. Thank you, everybody.
Thank you.
Can you hear me?
Yeah.
Yes.
Hello everyone, I'm Liu Wenjun, a fourth year undergraduate in Tongji University and now in Wuhan, and my time zone is GMT+8. It's an honor for me to participate in this workshop, and I just explored little in computational design and I have strong interest for it. The biggest point of this workshop for me is the potential of this new construction technology in near future, not only for pavilions, like with us, but also for buildings maybe. Yeah, looking forward to learn more with you guys.
Hello everyone, can you hear me?
Yeah.
Hello.
Yes. Yes.
I'm PhD candidate of Tongji University. I must have no experiments about the robot construction. So the reason why I'm here is I wanted to learn something new, some new technology, because it makes me feel excited. So I'm looking forward to learn more knowledge from Jacob and other tutors. Yeah, okay, that's all.
You're in China right now?
Yeah, I'm yeah.
Okay.
Hello, I'm Zhang Zhen. I'm also a PhD student in Tongji University. Nice to meet you, all of you. And I'm interested in this workshop for a long time, and I'm very happy I take part in it this year, and I believe I can learn and get more new skills from this workshop. Thank you. That's all.
Thank you. Okay, I think we only have one left.
Hello everybody, my name is Diego. I'm from North Korea. I'm graduate to Pyongyang University of Architecture. After that, I worked in architecture design in Pyongyang. At the time, I interested in digital architecture. Today, I'm happy to receive a lecture related to digital architecture for the first time today. Thank you.
Thank you.
Yeah, I think Yicheng have already introduced himself. So
I'm sorry. Can you hear me?
Yeah.
Yeah.
I didn't see the order just now, so I introduced myself in advance. I'm in Shandong province. My role is GMT plus 8. Thank you.
Thank you. Okay. Then the next point on our agenda is a break of originally 30 minutes. Maybe we start at 9 GMT. So in 15 minutes. Is that okay for everyone? Or should we do the 30 minutes?
Yeah, okay. Let's meet in 15 minutes.
Okay, great. You can stay in the Zoom if you want, if you mute yourself and stuff. You can also talk. Actually, we also have breakout rooms but maybe we'll do that later. Daihua, you want to run through WeChat problems with whoever couldn't connect to the WeChat group? You're muted.
I heard that some of you could not join the WeChat group or have problem. Yeah. And can you tell me what's the problem is?
Okay, welcome back everyone. For all the auditing students on YouTube, we'll put extra attention that the slides stay online or stay updated. This is the next presentation is meant to give you a bit of a background. Okay. Welcome back everyone. Background information about the context of multi-story timber construction and the relevance of our research and why we feel this is really important and of maybe almost global relevance. So around the world, the population is growing, and especially the urban population is growing. So we have estimation that 2.6 billion people will move into cities until 2050, which obviously is a great challenge for all cities around the world. And this means that for construction and for architecture, we basically need to double the building floor area in Europe. We need to extend the building floor area in other areas of the world even more. And basically, we'll have a necessary construction output of 65,000 square meters every hour. If we look at the construction industry, we can see that there is a big difference between the manufacturing and the construction industry in terms of its productivity. And we have a problem again in the live stream. Sorry, I need to fix this. I need to restart PowerPoint again. Give me just a second. Sorry. This is a new issue. Maybe it works if I go out of the... Maybe it's gonna work like that. Yeah. Okay, let's do it like this. Everyone in Zoom can still see the slides now, right?
Yes.
Okay. Let's do it like this. Sorry for the quick hiccup, but I think for the auditing students online, it's really important to also see the slides. Maybe I'll just start again. So we have a great population growth ahead of us globally. And this means that our cities across the world are going to grow substantially. It means that we are going to build substantial volume of housing with quite a big of a challenge of how we are actually going to do this, because the productivity of construction is stagnating since decades. There is a huge productivity gap that calls for new technologies. And if we compare the construction industry with other industries, we can see that that the productivity growth in the recent years might coincide with the digitization of the industry. And as for now, the construction industry really is one of the least digitalized industries. That means pushing digital technologies in construction has the big potential of also increasing the productivity. And in general, it's important to understand the economic relevance of construction and the relevance of research in that field. Construction is one of the least funded research areas globally, whereas the relevance of construction is huge. It's the biggest industry worldwide, and it has ecological relevance of global importance, with 40% of the resource consumption, 40% of the energy use, and construction altogether also produces 50% of the global waste. And at the same time, it's not only an economic and ecological factor, but it also is a great socio-cultural factor that plays into that, because the quality of the built environment will hugely decide the quality of our lives, as humans spend most of their time in buildings, and the quality of the building has a direct and long-lasting impact on the quality of the life that is lived inside. So I think these two curves really represent one of the core ecological challenges that we are facing. So we have a growing population growth, we have a growing amount of CO2 in the atmosphere, and really the question is, how can we reduce the carbon emissions while at the same time offering more building construction to all the so timber in this regard has a very interesting characteristic, as it binds 1 ton of CO2 in 1 cubic meter of wood. That means the trees during the lifetime absorb the CO2 from the atmosphere during the photosynthesis, and the CO2 is stored within the timber material. That results in an effect for building construction with timber that right now researchers around the world believe that timber buildings can become the biggest carbon sink in the world. And if you look at some examples of multi-story timber construction projects that were built in Europe, we see that the carbon that is sequestered in those buildings can reach beyond 1,000 tons of CO2 in a single building, right? And this is important not only to address the, let's say, the green, the climate certificate of each building, but also in a global context. And it's also important to understand how the forests actually work. So if you have a natural forest, actually a lot of the CO2 that the trees are absorbing from the atmosphere is gonna go back into the atmosphere naturally through the decay of the forest food. And given also that globally the use of woods is mostly defined by burning it, we can also understand that through burning the wood, the CO2 immediately goes back into the atmosphere, right? So actually, worldwide, around half of the harvested wood is just burned, which is obviously an important thing for cooking and heating. But it's also not really addressing, or it's not really a sustainable answer to how to address the carbon in our atmosphere. And then another thing that is important to understand is that whenever we're talking about the sustainable use of timber in construction, we are talking about extending the area of, like, the volume of forests globally, and we're not talking about deforestation. The main drivers for deforestation are mostly agricultural use. It's urban expansion, it's mining, and it's infrastructure. Whereas using the timber as a resource mostly leads to actually understanding the forest as an important factor in the development, and using the wood as a valuable material for construction can also lead to sustained forest management across the globe. The project that we see here is from Gustavo Otrabo. It was winning the RIBA Awards lately, and it's in the middle of the jungle in Brazil. And one of the interesting things that I understood in a conversation with him is that he's actually trying to teach the local craftsmen in the rainforest in Brazil to use the wood, to get them to understand the quality and the preciousness of the wood, and then to build back a understanding and the appreciation of the forest to manage it sustainably. The sustainably managed forests also come with the benefit that whenever you take away the biomass, whenever you harvest the wood, you basically reset the carbon absorption, right? And if you let the forest regrow, you're gonna absorb the same amount of CO2 again, right? So if we have a natural forest, we can see that basically the CO2 input basically is the CO2 output, right? Now in a forest where selectively you harvest the wood and you don't leave it to decay, you can see that basically you're taking away the wood material. You don't let it decay, but you use it in the building construction or as a structural member for any other type of use. And while the forest is regrowing, it will then absorb the CO2 again. And it's also really important to understand the curvature of this absorption, meaning that young trees really absorb more CO2 than old ones. That said, how the sustainably managed forests can actually lead to growing forests is shown very well in Europe, where during the last during the last between the time and the 90s, the forest areas increased roughly by the size of Portugal, right? While the use of timber increased at the same time, right? So we're using more timber, and at the same time the forests are growing more, which initially sounds like a paradox, but with the way that you can manage a forest, this is actually possible. And, I think this is really important to address because a lot of times the use of timber is seen as kind of like an act of deforestation. Now, if you're talking about timber construction, the question is how much wood is available for construction. And here it's really way more wood than typically we imagine. If we think about a forest that has a reproduction rate, if you will, of 50 years, right? And we assume that the buildings that we're building also live around 50 years. We could then, with the forest area in Europe, we could build all housing in Europe with 30%, with using 30% of the forest, right? So by using only a fraction of what is actually available for harvest, we can basically reconstruct our cities every 50 years. So this is really a huge potential. that we have with timber construction. And obviously right now, timber construction is rising. So it's more and more buildings built out of wood, but it didn't reach yet the majority, right? So we're around 10% of the built projects now in Central Europe. That said, all these assumptions or all these arguments are based on the sustainable management of forests. Right? If you just take away the trees without having them regrow, then obviously this kind of cycle will be broken very, very fast. Now, to give you a bit of a background context of multi-story timber construction, we can actually see that already in ancient times, and especially in the Asian regions, the use of timber also for a high-rise construction was actually already pretty advanced. You see the Tochi temple here in Japan in the year 800 in the 9th century, being 57 meters high. And then in the development of the centuries, especially in Europe, there was a couple of very big city fires that made the use of timber very controversial. The last, I would say in the 20th century, timber construction was mostly known for single-family housing and very cheap and fast construction. And only in the most recent years, in the last 2 or 3 decades, we can again see the technical development of multi-story projects built in timber going up in scale every year. In this diagram, the highest building is the Hoho in Vienna, with 84 meters high and 24 stories. But basically, this record is beaten every 2 or 3 years. So how come we are now building again in such great heights if we made the experience that the use of timber could burn down all of our cities? So to address this, first of all, in the Middle Ages, the fire codes and the understanding of what is actually leading to the propagation of fire was not as advanced as it is today. And at the same time, we now have timber products that behave very differently in fire. And to understand that, we need to make a quick differentiation between the combustibility of fire, of wood, which obviously is a given. All timber material is combustible, and you won't be really able to make it non-combustible. There is a lot of research about how to chemically treat timber to reduce the combustibility, but really this is mostly not working so well. But then, if we talk about the fire resistance of timber structures, this is a whole different story, where the recent development of engineered timber products actually And their study in fire tests actually showed that when you burn down a timber beam, the charcoal layer is gonna at some point insulate the inner layer from higher temperatures, and basically the whole it's almost impossible to burn the whole timber beam. A good picture that exemplifies that is this one. We can basically see the steel beams that were that lost their structural capacity because of the high temperature. And you have here the timber beam that is pretty much burnt down, right? It doesn't look so good, but it still holds up, right? So that's really an incredible factor in timber construction, where actually a lot of experts claim that building with timber might be actually more safe in terms of fire than building with steel and reinforced concrete. That said, obviously you want to always be very careful in how you ensure the fire safety of your about the mechanical properties of wood. They're quite a bit weaker than concrete and steel. But what is interesting is if you map the characteristic strength of hardwood and softwood against the material's density, then you can see that it's very much able to compete with other building materials, mainly concrete and steel. And that's very, very much important for any structure where the self-weight becomes a dominant factor. So that's typically for cantilevers, for long span structures, but also very much for high-rise construction. Where if your whole structural system suddenly is way lighter, then also the strength of the material is less critical. The mechanical strength of the material itself was also joined by recent developments in joining technologies for timber construction, where typically in, let's say, the traditional carpentries, we were mostly using integral joints. We then had the possibility to screw timber pieces together, but really the efficiency of the connection or the possibility to really efficiently connect timber pieces only came with the gluing of timber pieces, right? So a glued finger joint at the moment can reach almost 100% of the structural capacity of the as it's kind of connecting the fibers in the macroscopic scale. And this led to the most recent paradigm shift in timber construction, where from, let's say, a framed building, what we know as balloon frame and so forth, where you build up your construction from linear elements. The current trend goes very much towards planar elements. And those planar elements are built from CLT, where you have crosswise layers of boards that are glued together. Then what you get is a almost homogeneous planar building element that then is able to address the construction in an almost industrialized fashion. But if you look back at the intricate ways of how timber was actually joined before, and how also the machinability and the formability of timber allowed very intricate tectonic expressions, it begs the question of how new technologies such as automated fabrication and the gluing of timber could come together with more intricate tectonics of actually the timber elements. These technological advancements in timber engineering and timber construction currently are leading to a global trend of ever bigger timber buildings to be constructed. And even though the CLT development took part mostly in Central Europe, this is a technology that at the current moment is pushed around the globe, and really we can see a lot of investments of global scale being done there as well. I think everyone is aware of the startup Catera that is actually in terms of its funding already bigger than a lot of long established and traditional construction companies, with the goal of industrializing the construction of timber buildings. And this is maybe where we as architects need to be a bit critical about, where we say it's maybe exciting that there is new levels of productivity on the horizon, and that there is new technological advancements that are pushed forward. But also, if we look at the lighthouse projects of this kind of industrialized, prefabricated way of constructing the built environment, we can see that there is a clear restriction becoming apparent even on the first look at the project, right? So this is a project in Switzerland that was praised for its quality. This is also a very famous project in Austria by Hermann Kaufmann. One of the lighthouse projects in how to use timber in construction. We also have Michael Green Associates in North America who are pushing timber construction, timber architecture. Many people might know the student residence in Vancouver. And what we can see in all of those projects is a very rigid organization of the underlying grid and the structural system. And there is a very clear answer to the question why that is. And it's actually a very intelligent way of optimizing the construction of these buildings. It's based on the understanding that timber construction in these cases is always a modular construction technique, where either you have linear elements or planar elements or volumetric modules, but they're always prefabricated and they're transported and brought to site in the prefabricated manner. And while there is a connection between the level of prefabrication and the transportation volume, we see that whatever pieces you want to transport, they're always going to be limited by the capacities of the transporting vehicles. And this is to say that not necessarily that it's impossible to transport elements of, let's say, 5 meters in width, right? But it also gets very, very complicated and very expensive to establish these transportation schemes. So most of those projects try to kind of meet the size of a truck as exact as possible, right? And that leads to our buildings to be defined by the size of transportation vehicles. And while that makes sense in certain typologies of buildings, where a 6 meter long plate and 2.5 meter wide plate can quite suitably address, for example, a hotel room or a student dorm. It's not really suitable for other typologies where you might want to break free from these rigid grids that connect this. Now, the way that these products are manufactured is very, very much advanced, or did advance a lot during the last years. You can see that today there's a couple of companies who basically completely automate the production of building elements, be it slabs or walls. And that obviously is a big potential for the industry. And what is important though to understand is that while at the current moment the market potential of this kind of modular construction systems is hyped very much, this is a study from McKinsey that estimates the market potential of modular construction to be $135 billion, right? And says basically that the modular construction market is going to be growing and growing and growing. What we as architects maybe should not forget is that the 135 billion market potential are still a fraction of what is actually the construction market in total, right? So at the current moment, we have the total construction volume, and around 13% of this volume are possible to address with building systems, and 87% of the future construction market, as estimated by McKinsey, can't be efficiently addressed with modular and grid basement. Because for these systems to be economically viable, they need a high amount of standardization and repetition, and all the building elements basically need to be fitting into what we can transport on the road. And also from an architectural perspective of the spatial quality, we somehow must admit that this type of modular construction is maybe somehow not the most exciting spatial expression of what is possible. And especially if we compare it with concrete building systems, we can see that there is one very clear difference between what we are currently doing in timber construction and what is going on in concrete. And that is that at the current moment, timber building elements and structural systems are always reinforced linearly, right? And even though CLT has somehow of a two-directional structural capacity, there's always a predominant direction of the span that is defined by the top and the bottom layer of the CLT. And that really much restricts what we can do with timber. Whereas in concrete, by the way of laying your rebar in whatever shape you want, you can actually address more or less very free topologies of slabs, right? And this obviously can lead to very expressive interior, exterior, and spatial qualities of the buildings that you can build. And this is not to say that it's impossible to do this in timber at the current moment, but really the systematic and integrated systems of how to construct these things are not yet developed, right? And you will see that most of the projects that address similar spatial qualities often are very much involve a lot of manual work. So what we're really interested in is not to negate the linearity of timber as a material. So because of its fibers internally, wood will always try to work as a linear structural member, right? But by by arranging the linear members in a more adaptive and maybe in a more complex way, we might be able to actually join them together in more structurally viable building systems. This is the slide that I showed already in the quick introduction. So whenever we have specific situations that beg the question of whether they are really most sufficiently addressed by a linear span, in those situations, we might be very much able to not only increase the aesthetic quality or the tectonic quality of the slab, but actually also introduce a material efficiency and performance parameter that would not be possible to address with conventional construction systems. So what we are really looking for is to move from a unidirectional span timber building system to a multidirectional span system, and to evolve from a grid-based layout of your building to a network-based layout building. And what that entails in terms of the fabrication is that instead of having transportable modules that you plug on site, but have them produced off-site, we are looking into how how we could have modular and transportable robotic platforms that can address the same benefits of the transportation, but then can break free from the constraints of the transportation constraints for the building models. And with that, we're trying to achieve, instead of a segmented single span slab, we're trying to achieve monolithic and multi-directional slabs. So for the workshop, the way we are going to address this, I'll just repeat it. So for the live stream and the auditing students online, we have basically two scenarios of how our mobile robotic platform can actually build monolithic and multi-directional slabs. And the scenario A is where the robot moves below a pre-hung timber panel slab and reinforces that with the beam structure underneath. And the second scenario is where you basically lay out your base panels flat on the floor, and the robot is crawling on top of the panels and reinforces it incrementally. And the whole slab is later pulled up on the columns into its final position. And what I think is very important to address is that the way the beams are arranged and their tectonic articulation is going to hugely impact both the fabrication speed, but also the structural capacity of the timber slab. So we are really interested in seeing what are effective ways to organize your linear elements into these complex networks. And this is the robotic fabricator. As we already discussed, it's very much suited for working on both on the ceiling and on the floor. And we're going to have a more in-depth introduction into this tomorrow. Just as a quick repetition from before, this is the fabrication process as we envision it, with the scanning happening at the very first iteration. We grip the beam, then we apply glue. We position the beam, and we fix the beam with nails so that the piece is held in place until the glue hardens. And with that, we are through with the relevance and context presentation. Maybe we can have a quick Q&A, and then we can run. We can continue with the schedule and the first exercises in recipe.
No, there's no for the question. Do we have the limitation of beam joint in just the 3 angles? No, we don't have this limitation. The angle is free.
Okay, then Mahmoud is asking about the durability and the profitability the systems compared to concrete. So the modular timber construction building systems with CLT are starting to be very much competitive with concrete. That said, within this specific market sector of wherever modular construction is applicable, especially in situations where the time of the construction on site is highly relevant. Prefabricated modules are actually already by far offering better economic returns of investment. The durability of timber construction depends on the technical quality building. So there is buildings in Europe that are actually the oldest buildings, or some of the oldest buildings in Europe are timber buildings. So they can withstand hundreds and thousands of years, but only if they're protected properly. So if they get wet all the time, then they're gonna break down.
Maybe you know there's a high-rise tower, wood tower in China, a pagoda. It was been built like 1,000 years ago, and it have went through the several earthquake and also the Second World War, and now it's still standing there. It's like all the you can find no nails in the tower, and now after 1,000 years, all the timber it's like they all grow into each other, and it is hard to separate all the elements, but the structure is still strong. I think that could be evidence for the durability of timber structure. Maybe.
Is there potential design space for non-vertical layers? I'm not sure if I understand this.
Maybe you mean that you want to
stack them next to each other?
Not layer by layers, just stack up layer by layer. But I understand you want to develop something more innovative, and we also appreciate that. And I think the tools we provided, and it's just what Jakob had just talked about. And I think if you think you have the skills or and you want to develop something more, I think you can also use this develop your own structure building system based on the concept we are proposing here. Is that right?
Definitely. I think we'll offer a system that that we think has a pretty comprehensive set of situations worked out already, and we definitely support you if you want to change the system, right? But I think it would need to be also addressing all the aspects. So it would need to be fabricable. the robot platform, and need to address how it works on as a tectonic system. Okay. So, are there any more questions? Yeah, Ben is saying that the nails would have probably already rusted for 1,000 years. I guess I second that. Yeah, I think just the whole question of the durability of timber mostly revolves around moisture. As long as your timber construction doesn't get wet, you're pretty good to go. Even without any chemical treatment, right? You don't actually necessarily need surface treatment of the timber to keep it from surviving hundreds of years. What you very much need is to make sure that it doesn't get wet. Okay. If there's no more questions around this, then what we will do now is to go on with the interactive skill up, where we will run through, let's say, a very much simplified way of how we can arrange timber beams in a slab, right? And the main point of this exercise is actually not to really design a valid structure, but mostly just to warm up our skills in Grasshopper, and we'll just give you an easy exercise until tomorrow. We can play around with what we're showing. But I think we can do another 10-minute break before we start with that.
And the live stream online is black now. All right.
Yeah, I'll put the schedule back there. So we'll continue in 10 minutes with the Grasshopper and Rhino fill up. All right. Should we continue? Any objections? Good, then let's go. Honestly, I didn't look at the time, if it was exactly 10 minutes. But gonna be recorded, so everyone can have a look later online. Good, so what we're gonna do now is to do a very, very simple design exercise where we're gonna do, oops, actually I need to put this in the possible to see, where we are just gonna arrange quite randomly timber slats in a somewhat weird way, right? But it shows a certain expression. And in this case, I guess the structural idea behind the whole thing would be that you have kind of tension rods on the outside, and the cantilevers to all different directions is held in place by those cables. I think it's more or less irrelevant whether that really makes sense or not, as mostly the question for us is, how do we get these kind of timber elements to be arranged in such a way? And we can discuss whether they're on top or actually below, right? So both is possible. Obviously very different quality of the space below it. And what we actually need to design such a structure is really not so much. We have here a grasshopper script that, in terms of length and complexity, is really what I would say is a good level for starting. And basically, the only thing that we're doing is we're taking a curve, we are defining, we're kind of constructing a pipe, and we're populating the pipe with random points. So really what we call the tectonic articulation in this scenario really is just a random population of the volume, right? So this exercise, I can only say again, does really not make too much sense in terms of the actual design proposal, right? It's really meant more to start playing around with Grasshopper and start understanding the very basic principles. So we populate this kind of volume. We then kind of get the direction and start making planes. Okay, I see that they're actually quite small. Starting to construct planes that have the x-axis oriented in the correct way. And then all that we're doing is we're constructing boxes in each of those planes. Right? So I think that's really hopefully a good way to get going in Grasshopper. We're gonna run through, I think we can just build the whole script now together. But before we start, I guess the question is if anyone needs assistance to get Grasshopper started. If anyone has problems running the program on his computer. And then we're good to go. No questions? Everyone set to start plugging in components?
If you have any question, just maybe text in the chat window.
Yeah. You can. What we can also do is that you can just talk to Hua also while I'm running. But in general, we have enough time to take today's lesson really slowly. So just let us know if we're too fast or if you want a bit of extra explanation on something. Okay. I'm gonna make this curve quickly. So let's start fresh. Obviously, we can also send out these files later, but I think for now, let's try to have everyone construct their own files. Just gonna open a new Grasshopper file now, and all I have is the curve. Yeah.
Everybody could follow Yag.
Does anyone need a bit more time to start Rhino and Grasshopper?
Maybe we just move on. And if you have any question during the tutorials, you can just text me, and I'm all available, I think.
Yeah. Okay. So what we do is we start with a curve. In case you need the curve first, you can do it in a couple of different ways. Where's my curve? Easiest is just to use the curve command or some weird curve. I think the point being it should look a bit funny, like something like this. Almost an S, but not really. Then you get it into Grasshopper, double click on the canvas, and you type curve. Or alternatively, you can get all the modules in Grasshopper from here. Okay. Curve module, you get it here. And then what we do is we start referencing this curve. Oh. And now first step that we want to do is to pipe the curve, and we want to pipe it variable. So lots of different ways of how we can do that. The input for the pipe component first takes the curve, and then it takes a set of curve parameters and the respective radii. And then we can specify if we want to have the pipes capped or not. Right? So what is the curve parameters? If we look at the curve, we can actually understand the parameter as kind of the percentage of the movement from one end to the other. Typically, this is from within a domain between 0 and 1. So if we want to evaluate a curve, we can say we want to have a number slider from 0 to 1. We plug it in here. Then we can see, okay, this is the start of the curve, right? And we can basically run our point along the curve in whatever way we want. So if we say we want to have the radius of the pipe to be 100 at the beginning and 500 at the end. The way that we would do that is to say we make two sliders here. You click and you click with the left mouse button and you hold it, and then you press Alt. You can copy components. And we say, okay, we start with 0 and we go to 1. Now, if you want to have a second input, you should press Shift while you're plugging it in. And then we have one slider with 100 and another slider with 500. Let's see, we've got this guy. Oops. And now we have a very simple variable pipe. Fully parametric, right? Means we can make it thicker or thinner. And actually a more clean way would be to say we control the sequence of those parameters with a merge component. And now, in theory, we can also include, let's say, a parameter in the middle. Where we say maybe actually we want to start a bit thicker. We want to start thicker and then get thin, then get again a bit thicker, and move that point on the curve. Good. Now we add a Boolean toggle to specify if we want to have this capped or not. Yes, I'll say yes, I want to have it capped. What's the difference? So if I bake this guy, this is really a pipe, right? So it's hollow. Whereas if I cap it, then it's a solid, right? Then it's a closed poly surface. I guess we want to have a closed poly surface for now, because maybe maybe what we want to do actually is to trim it on the bottom, right? So that we end up with half the pipe, right? So let's try if that works actually. Times Boolean operations are a bit tricky, but we want to make a solid difference.
Sorry, Jakob.
Yeah.
Yeah, there's a recommendation from the participants that you can switch Grasshopper to use full name. So they can know.
Yes, I don't like it so much, but I understand that it's easier to follow. So I guess let's do the full names. Is that better? I guess I work very visually in terms of how I see components. But I think this is now easier to follow. Okay, so let's try the solid difference. Important for the solid difference, this needs to be a solid, right? So we need to have it capped. And actually, I'm gonna bring this back in a form where a bit thicker. And now we bring the box into our grasshopper. And then we say we want to subtract from the pipe the box. And now see what that. So now we have half a pipe. And we can still play around, but obviously now it's also going to be a bit slower. Boolean operations. times take a bit of processing power. But okay, so far so easy. Then what we can do here is just say populate. Right? So what do we need? We need the geometry. That's this guy. And we can specify the number of points that we want to have. So let's make a slider to control this. Actually, more than 100 would be actually. And we can basically specify how many points we want to have. Now these are random points within our solid, right? So they are inside they are placed all around the thing. We can also specify a couple of points that we want to have already fixed, right? In our case, we don't need that. For the seeds, we can put whatever we want, right? The seed is basically resetting the randomized. If you're not happy with the random result, then you can change that. Try a different information. Okay, now we have a couple of random points, and if we now want to make boxes out of them, if we just plug those, what's gonna happen is, okay, we need to put the domains -2. First construct the domains. Oh, that's so big. I'm gonna put this here. Here we basically need to decide how long our last elements. So what happened? You have a couple of boxes, but they're really not very nicely arranged, right? Actually, I need to plug these guys in. So they're all now 1 meter long, right? From the middle -500 to +500. They're all 40 millimeters wide and 40 millimeters high. But their arrangement is based on the world coordinate system, right? Now what we want to do is to actually align all these elements with the current orientation of the curve, right? What we're going to do is to find the closest point on the curve. We have these points and we have our base curve, and so for each of these points we find the closest point on for each of these points we find the closest point on the curve. And then what we want to do is we want to evaluate the curve at this point. Let me just do this a bit. Fill our curve here, and if you take this parameter, if you remember, that parameter is the position on the curve. Right? Take this parameter, we plug it in here. We're gonna get for each of these points, we're gonna get the tangent on the curve. So to display that, we can show the vector. So we show point, then we show the tangent. I'm gonna make this a bit longer. One more. Right? So for each point, we now have the vector that follows the curve. And with this vector, we now want to construct a plane, right? So we do a plane construct. We need the origin for each plane, which is this. And then we say the tangent vector becomes the x-axis. And then we need the y-axis, right? Which would be in this case, actually, it already always assumes the right y-axis. But we could also define that. And we could also say it's always set. Right? Then we're very clear what happens. Because we define first that the x direction of our plane goes along the curve. And we define that the y direction goes always top. Now, if we plug this plane into our base or our boxes, then we can see that actually our sticks are now very much aligned with the geometry. Now if we hide a bit, now increase the population. gonna have more and more sticks flying around, right? This is really a random approach, but this is fun to start playing around. Now, maybe we want to make our sticks a bit thicker. Set this up actually not. So y, if you remember, is our height. Let's say we have 20 millimeter high beams. And we say there are maybe 60. Could be even more. Now there are much more. And now with this, you can basically already do a very fast design proposal, right? Like this, maybe you make them a bit more. Maybe you say, okay, I fixed everything. Now I want to say, let's fill it up with beams. Okay, wrecking my computer. And bake those guys. And you have a fun random arrangement of intersecting and overlapping timber beams. But maybe for showing an initial design, it's actually already quite powerful. Now, if you saw what happened here is that actually the population of points is only on the outside, right? It's only on the surface of our volume, which is okay. But also what we can see is that actually maybe we want to control a bit more, let's say at least the height of the beams, right? So that we at least know that they touch each other on top and on bottom. So maybe we run through a quick Q&A of whether there's any questions regarding this. If everyone reached the point of managing this little script, and then we continue to address the different heights.
No question in the chat.
this a bit bigger now again. We actually don't need, right? Just use it to explain the curve parameter. We have our curve. We have a B-rep reference that is just like sitting below the surface. Define our pipe. We make the difference, solid difference, the Boolean difference. And we populate the shape with our point. We check the closest point on the curve. We get the tangent of that curve point. And we construct our plane that is oriented along the curve. Then we build our box with 3 domains that look very complicated, but in the end we're just setting the boundaries of this boundaries from the center point. Okay, so what do we need to do to get all the beams in different layers? What I would suggest is, after my crossover, no, where is it? There we go. Actually, I'm gonna save this now. Okay, so what I would propose is to, instead of populating the full geometry, we first slice the geometry into layers, which means that we control the vertical arrangement, all of the layers. And for that, first I'm gonna remove this thing, and I'm gonna remove our back geometry. And what we have is our pipe, right? And it's a closed thing. And now what we could do is to try if we can contour this. So we have our shape. We take the XY plane as our starting point. We take the Z vector as our direction. We say we want to have a layer every 30 millimeters, maybe. And what that gives us now is a layer for each, basically a slice of our pipe in each iteration of 30 millimeters. Let me just clean this up a bit. Now we have 25 contours. And what you can do is here to do a boundary surface around those. So these are curves, right? Now what we want to do is to make them surfaces. So if you bake those guys, you will see that these are each a separate surface, right? And now, of course, we can do the same population. Instead of on the whole geometry, we just do it on the surfaces. Now, maybe I'll just do that, but there will be a problem that we're going to see very fast. We have the geometry. And let's reduce the number of points for now, that we all have a bit of an easier time for computers. Let's say 10 points on each surface. Now, what is the problem? The problem is that that the small surfaces on top receive the same amount of points, right? So this small thing here is going to receive 10 points, and the one on the bottom is receiving also 10 points. Right? Whereas really, I guess we want to have an equal population for all the layers. So I guess what we can do is we can check the area of these surfaces, and so that's square millimeters. Divide that by this. So we can see the area goes from 11 square meters to 0.3 square meters. Right? So it's very much different areas, right? And now what we can do is we can just remap those values. And we say we want to remap them from the source bounds, right? Look here, from the smallest being 0.34 to 11. We want to remap those values to, and now I'm running out of space here. We're gonna remap them. The number of beams per square meter, right? So if you take the if we say we want to have 10 beams per square meter, we multiply the lowest area with 10, and we multiply the highest area with 10, and we construct our domain again. As we did before. We're gonna say that the number of beams depend on the area. And we remap the area size with that. Now, actually, I just realized that we could also just remap. We can just multiply the area with the number, right? So actually, we could just let's make this a bit simpler. Don't need this. We don't need this. We just say we have the area in square meters, and we want to have 10 beams per square meter. Gonna give us a couple of values. So for the big panels, it's 120 beams. For the lowest ones, it's only 3. Now we want to make we want to feed those into our counts, right? So for each of our sections, we want to have a specific count of population points. Try that. Okay, so now go inside, we can see it's nicely populated in the middle also, and it seems it's also populated very uniformly, right? Still very much random, but at least it's kind of uniform. Let's just reduce the beams per square meter. Okay, and now with this population, we basically do what we did before. We construct our planes. that always look into the direction of the beam. And then we have a look at what the boxes result in. Now, they're not touching yet, right? Because we didn't define the correct height. I guess we set the height to be 30. Let's make this 40. And let's make the height of the beams also 40. Okay. Now this is maybe not enough beams. Push this back to 60. And now we have all the beams sitting nicely on top of each other, right? Obviously, we still have a couple of problems. Here, these beams overlap quite drastically. Also, we don't really know how the beams are connected. So I guess this beam here, for example, doesn't really have a place where to connect to. It's really not great if you really want to build something. I guess for doing a quick rendering, this is already pretty powerful, right? So let's say competition stage, this is good.
Any question?
Actually, there are some questions in the live stream.
I see that, but it's hard to. Yeah.
I see Mahmoud's text now. I mean, that's, yeah, so this is exactly what we did, right? I guess you wrote that before we did it. But this is exactly what we're doing here. I guess my first approach was very complex. But basically we take the area and we multiply by the number of beams per square meter. Maybe let's go through some of the questions in the live chat. I have an issue with the pipe variable. It doesn't work. That's maybe hard to answer. But I guess what might be the problem is that if you input your list of parameters and your list of radii, both lists need to be numbers, and both lists need to be the same size, the same length. If I unplug one of these guys, I'll have immediately an error. So just make sure that you have 1, 2, 3 parameters here. You have 1, 2, 3 parameters here. And then another problem that might appear is that your parameter domains for that curve are maybe not matching. Right? So what I did here is to reparameterize the curve. That means the beginning is at 0 and the end is at 1. And then my parameters are also within 0 and 1. I don't know what happens actually if I push the boundaries of this. But I guess it would throw an error. That might be a second. Yeah. So if I go beyond the curve domains, I don't get a. So make sure to reparameterize your curve by right-clicking, pressing reparameterize, and then set the domain of the curve parameters only between 0 and 1. Screenshot of Grasshopper. I didn't clean it up yet, but anyways. Right. Where did I see it?
To evaluate the tangent of the population to find the closest point of the point in the population to the curve. And use the curve closest point, you will get a t parameter. And use that t parameter to evaluate the curve. Maybe Yago could show you later.
Yeah, send the picture. Not sure if I can send it also in the YouTube chat. I guess no. No. Can you still hear me? Okay. Any other questions?
Is there the one from?
Okay. We can also show this here quickly. So the area, as my model is in millimeters, right? This number is also in millimeters with exponent of 7. Right? So it's a 1 with 7 zeros. And what I'm doing is I'm just dividing by 1 million, converted into square meters. Right? I guess 1 meter equals 1, 3, 1, 2. Per millimeters. Right? This is what I'm doing here. So this one is actually in square. Which input?
You have explained that.
Okay, now this problem is solved. And how did you evaluate tensions after population?
Already done.
Already done. Good. Then I guess then I guess we were quite fast with that. I think what might be interesting is to see how you would use this kind of script to populate your slab, create kind of beams within a slab. Right? I think that would be a nice exercise until tomorrow, where each one of you can basically design their own specific situation and just use what we learned today for creating a network of beams to support that structure. Right? I guess what we showed here really maybe only a very basic sketch, right? I mean, none of those beams are crossing each other. But you can already start with this kind of idea. You can already start thinking about what would be the spatial organizational principles that you would like to explore within the workshop.
You think we still have like half an hour left?
Yeah.
And the talk of Agin starts about start
at 2. Well,
2.
At 12 GMT.
Yes.
In half an hour. So I guess what might be good is we take a break now, give everyone the chance to have lunch, dinner, snacks, quick break, and then we can all watch the actually share it here quickly.
There's a question from Vicky, does the rooftop have to be flat or it could be a curved surface?
Good question. I guess it would be a bit complicated to. Where's our beam here?
I think in this case, it really works on curved surface as long as you have a 3D curve and the brick that you use to calculate the difference of the pipe and the roof need to be the shape of your roof. That means you need to cut the pipe with a brick that generates from your curved roof.
Yeah. I guess the question is what you want to achieve, right? I guess in terms of the topic of the explorations that we're really interested in, the question is really how to address timber slabs, right? So if you have a look at these kind of situations, right? The majority of our built environment is built with slabs, right? Which is just like the most important organizational principle in construction, right? To kind of multiply the surface that we inhabit in different floors. And I guess, I mean, if you look at the Sana building, right, you can also inhabit kind of undulating, three-dimensionally formed surfaces. But really, I think the most performative surfaces sometimes are, or in terms of their use case, are just flat. Right? And I think in the next days we're gonna see how complex already the planning of just a simple flat slab can become. So I would propose that everyone kind of sticks to the flat topology. But if you find a way how to come up with a concept where you really say that the undulating articulation of the slab is gonna add additional value to your building, either spatially or functionally, right? Then I guess that's up to you. Just be aware that it's gonna add complexity. Okay, so Chai-Hua sent the link. But
it's a link to the talk later about him.
Yeah.
The same link.
Great. So let's check the channel. Okay. Currently going on with Michael Weinstock. So I guess at the same location you're gonna find the talk with
yes.
Of Achim with Philip Juan, Arete Marco Polo, the director of IAC, Bob Scheel, director of UCL, Bartlett, and Mette Thompson from CETA. And I guess what we're gonna do is we're gonna send out 2 links to Google Drive folders, with each one having a different use case. The first is where we will share our resources with you. The second is where you can put your models, your projects, and I guess, or your exercises. I guess what we would ask you to do is, until tomorrow, use the logic of what we showed today, and you upload your own version of this kind of very simple diagrammatic design, and we'll have a very quick session tomorrow where we go through your explorations. And with that, I guess we call it a day for today. In terms of the streaming and tutoring, and we'll also send out the list of participants with the mails and the time zones, so that you can start organizing yourself already, in terms of maybe helping each other out or just chatting. I don't know, maybe you want to get in contact. I'm actually, what I might be able to do is to set the Zoom room, so the room that we are right now in, I'm gonna try to set it in a way that you can get inside without us being here. Right, so you can, whenever you want to talk to each other, you can also just use the same kind of platform here.
Maybe it's not possible for this room.
Oh yeah.
When this room was created, it have a time limit. It will end at some point, and we could not change that.
Okay. Okay, we'll discuss that and then send it out per mail, I guess. But I guess we would definitely try to find a solution where you as the participants can all talk to each other, or very easy. Actually, just see that in the live stream there's another question.
Also a question.
Yeah, I guess we can send out the code to everyone that is on the auditing student list. As we have the emails of you, we can just send you the.
First question here. Today we are not going to divide you all of you into groups. You are going to work on your own just for today, and from maybe from tomorrow, from the day after tomorrow.
From the day after tomorrow, I think. From Monday on, we will split into groups.
Yes.
Of 2 or 3 people each. Okay.
Yeah. Okay.
Thank you all for being here. Enjoy the talk with Achim and Philip and all the friends. And see you tomorrow at the same time. And have fun with the script.
Okay.
See you all. Ciao.
Bye.
See you.